Now we can examine the very first case study, which is the Netherlands. So what is the Netherlands case study about? Well, it's about a greenhouse and how water and nutrients can be recovered and reused. In the case of the Netherlands, the first thing the user can influence is the rainfall. Why is that? Well, it's because in the case of greenhouses, they use surface water from reservoirs mostly. Tap water is pretty expensive, while surface water replenishes itself over time and is therefore a much cheaper alternative. So what will happen is uh, the user can change the amount of rainfall so as to simulate the scenario of water scarcity. And in this particular case, then suddenly being able to recover and reuse water become a lot more important. Similarly, users can change the irrigation technology, um, and its efficiency, the storage capacity, which define the resilience for water scarcity. And the heart of the interactive system in the greenhouse is there. The place where you define the surface area, how big is your greenhouse, how much do you cultivate, that will definitely change your water requirement. So if I um, change the surface from 8 to let's say 11 hectares, then suddenly you can see your water requirements going up. And you can also change the crops. So some crops are more um, hungry for water and nutrients than others. So if you change the way you plant things in your greenhouse, you can, for example, have two types of crop instead of just tomatoes. So you add cucumber, 50% cucumber, 50% tomatoes. Where you could see your water and nutrient requirements are going down because of this particular change. Um, One of the most important aspects of the Netherlands case study is that you've got this cost benefit analysis there that shows you what you gain, what you save money wise, water wise, energy wise, when you use this electrodialysis technology to recover water and nutrients as opposed to the standard filtration system known as reverse osmosis. So there is a significant amount of savings in that case that can be uh, realized. There are extra things that are visible in the results section. You can see the share of used nutrients, and also you can see it by mass. You can also see the percentage of nutrient reuse, how much do we recover. And there is a little bit about water quality. So what happens once the water has been discharged, or what is the status of the water quality just before it's being reused. There are also some interactive Sankey diagrams that will show you the flow of water, what is being lost, what is being reused in a more graphical manner. Similarly for the flow of nutrients. And finally, there is a small table that shows you the quantities of fertilizers which are used or saved depending on the type of recovery technology you use.